Okay, this video is to help you out with question number 4 of the post-lab analysis. It asks if you mixed exactly 10 milliliters of 0.1 molar sodium hydroxide with 9 milliliters of 0.1 molar hydrochloric acid, what should the pH be? So this is what you did in lab the first time you mixed the two chemicals together. And if you did it this way, you should have found that the pH was in the range of the 11s. But we're going to go calculate what it should have been. And so what we have to do is look at the reaction. So the reaction being done was sodium hydroxide plus hydrochloric acid, and it was going to make water and sodium chloride. So the idea behind the titration was that it was a controlled reaction. You were controlling exactly how much of each thing that you had to use. And so if we look at the sodium hydroxide and look at how much we had 10 milliliters of 0.1 molar sodium hydroxide. We can actually use that. This is our volume and this is our molarity, to go find the moles of sodium hydroxide that we had. Then we also see that we had 9 milliliters of 0.1 molar hydrochloric acid, and we can also go see how much hydrochloric acid we had. Now you should be able to see just from looking at that we had more sodium hydroxide than hydrochloric acid, and so we had an excess of the sodium hydroxide. Your pH should have been a basic pH when you mix these two things together, because you had excess of the base when you're controlling this reaction. But we're going to look at the actual numbers. So if we use the sodium hydroxide and we plug into our molarity formula, the molarity is moles over volume, and remember that our volume has to be in liters. So we convert our milliliters, 10 milliliters, to liters. This one right here is 0.010 liters. This one right here is 0.009 liters. We find that we have 0.001 moles of sodium hydroxide. So if we repeat the process for hydrochloric acid, we would do 0.1 equals moles over 0.009 liters, and we would find that we have 0.0009 moles of sodium hydroxide, or hydrochloric acid. So looking at that, we have 0.001 and 0.0009. So when you see these numbers, you can see that the sodium hydroxide is the higher number. So you're going to have excess of it left over. But you want to know exactly how much excess you have left over to figure out the pH. And so what we did with limiting reactants, we were given amounts of both reactants, is we picked one of them, and we saw how much of the other that we're going to need. So I'm going to pick the hydrochloric acid, because I can see that that's going to be my limiting reactant, so I'm going to go ahead and pick that. And I'm going to use that to calculate how much sodium hydroxide I would have needed. So I will just simply use the mole to mole ratio, which is a 1-to-1. So I would get 0.0009 moles of NaOH, and that's how much would have been needed. Well, what we want to do is figure out how much is left over, because that's what's going to control the pH, is this leftover sodium hydroxide. So back when we did limiting reactants, we said, okay, how much would be left over? We would take how much we started with, and we would subtract how much we needed, and we would get 0.0001 moles left over. So that's how much NaOH we have left over. So what we do need to understand is that we have no hydrochloric acid left over. That was the limiting reactant. It's all gone. We've turned that all into salt and water. Well, the salt, the NaCl, and the water are not going to affect the pH, so we're going to ignore how much of those that we made. But the sodium hydroxide that we have left over definitely will affect the pH. So we learned that pH can be found from the negative log of the H+. But we don't have H+, we have OH. So we're going to have to use POH, the negative log of the OH. However, those brackets means it has to be concentration, which is molarity, and right now we have moles. So what we need to do is figure out the molarity. So we know that we have 0.0001 moles, but we need to know how much volume we have in order to figure out the molarity. And this is where you got to pay attention, that when we've poured these two things together, the 10 milliliters and the 9 milliliters, you now have 19 milliliters in there, which is 0.019 liters. Okay? So if you take those two numbers and divide them, you will get that we have 5.26 times 10 to the negative third as our molarity of our NaOH. So when we go find our POH, we simply do negative log of this number. So the POH comes out to be 2.28. And then to find pH, we would take 14 minus this, and get 11.72. And that's what our pH should have been. So you can look at your information and see how close you actually got to that value. So I'm not going to ask you for detailed calculations like this on your post-lab quiz, but I will ask you to predict what the pH should have been if I give you amounts of acid and base. And so you need to understand that whichever one we have more of is going to be the excess reactant, and that's going to control the pH. So if we have more base, we're going to have a basic pH. If we have more acid, we're going to have an acidic pH. If we have equivalent amounts of both of them, we're going to have a neutral pH.